In this video, we're going to solve question 39 of 2021 Junior Mathematics Olympiad first round. We're asked to find the number of factors, including one and itself, that the number 576 has. Okay, so I'm going to talk about a way of calculating the number of factors a number has. So let's start with a small number like 24. So if we were to list out the factors of 24, we'll have 1, 2, 3, 4, 6, 8, 12, and 24. So 24 has 6 factors, for example. Okay, let's talk about something now. Let's write 24 as a product of powers of its prime factors. So the prime factors of 24 are 2 and 3. We can write 24 as 2 raised to power think 3 times 3 raised to power 1. Okay, 24 is 2 raised to power 3 times 3 raised to power 1. And at this point, we're going to do something. Let's write out all the numbers from 0 up to 3 and numbers from 0 up to 1. So for this, we'll have 0, 1, 2, and 3. And for this one, we'll have just 0 and 1. So if you pick a number, any number at all, from this bracket, and pick any number from this bracket, and raise 2 to the power of the number you pick here, and 3 to the power of you pick here, and multiply those numbers together, the number you have will be a factor of 24. So let's say we pick 2 from here, and then we pick 3 from us, and we pick 1 from the other brackets, right? So the number we're going to have will be 2 raised to power the first number we picked, that's 2 raised to power 2, times 3 raised to power the second number we picked, which is 1, 3 raised to power 1. And this will be 4 times 3, which is 12. And 12 is a factor of 24. Notice that we have it up here. If we pick a different pair of numbers, let's say we'll pick 1 from the first bracket, and then we'll pick 0 from the second bracket, then the number we're going to have will be 2 raised to power 1 times 3 raised to power 0, which will be 2 times 3 raised to power 2 is 1, that's 2 times 1, which is 2. And 2 is a factor of 24. Notice we have that here. So the reason why this works, the reason why if you pick a number from this first bracket and pick another number from this second bracket, those two numbers, 2 raised to power the first times 3 raised to power the second will be a factor of 24. Or let me describe why that works, right? So let's say we have 24 divided by the number you pick. So write it as 2 raised to power 3 times 3 raised to power 1. So let's say we pick x from the first bracket. Then in that product, we're going to divide by 2 raised to power x times, and if we pick y from second bracket, we'll have times 3 raised to power y. This here is going to be 2 raised to power 3. Since we're dividing by 2 raised to power x, it will be 3 minus x times 3 raised to power 1 minus y. And notice that the values that x can take are the values 1, 2, and 3 from here. So the value of 3 minus x is going to be non-negative. So it's going to be a non-negative integer. It will either be something from 0 upwards, right? So this number here, this power here, is going to be non-negative. It's going to be a non-negative integer. And this power here, 1 minus y, since the numbers we can put in place of y are just 0 and 1, this 1 minus y2 is going to be a non-negative integer. So at the end, we're going to end up with a number that is going to be a whole number here. So if when we do 3 minus x here, we have 1, and when we do 3 minus y here, we have 0, then we're going to end up with 2 raised to power 1 times 3 raised to power 0, which is 2, right? Which is a whole number, which is an integer. So that's the idea behind this. So if you pick a value of x that is less than or equal to 3, that's the power of 2, and pick a value of y that is less than or equal to the power of 3, or the second number, then when you divide the original number by that new number, you're going to have a whole number. Because let's say if you divide 2 raised to power 3 by 2 raised to power 4, so if you divide by something that is bigger, that's when you start having fractions like 1 over 2 and so on, right? So that's the idea behind this. So what this means is that there are as many factors for 24 as there are possible ways of picking one number from the first bracket and picking a second number from the second bracket. And notice that in the first bracket we have 4 numbers, in the second we have 2. So we should expect 24 to have 4 times 2, which is 8 factors. And indeed 24 does have 8 factors here, right? So that's how this works. So let's talk about a bigger number. Let's say want to count the number of factors that 150 has. If you write 150 as a product of its prime factors, you have 2 times 25. Sorry, this is going to be 2 times 3 times 5 raised to the power 2. So that's 2 times 3 times 25. And then just as we did before, we're going to like create, let me call them brackets for each of these, right? So for this, since this is 2 raised to the power 1, the options we'll have here are 0 and 1. Since this is 3 raised to the power 1, the options we'll have here will be 0 and 1. And since this is 5 raised to the power 2, the options we'll have here will be 0, 1, and 2. Then if you pick 1 from this first bracket and pick 0 here and pick 2 here, then the number you have will be 2 raised to the power 1 times 3 raised to the power 0 times 5 raised to the power 2, which will be 2 times 25, which is 50, and 50 is a factor of 150. If you pick 1, 1, and 1 from all 3 brackets, then the number you have will be, so if you pick 1, 1, and 2, to be 2 raised to the power 1 times 3 raised to the power 1 times 5 raised to the power 2, which is what we started with initially. That's just 2 times 3 times 25, which will be 150. And 150 is a factor of 150. If you pick 0 in all 3 brackets, then the number you have will be 2 raised to the power 0 times 3 raised to the power 0 times 5 raised to the power 0, which will be 1 times 1 times 1, which is just 1. And 1 too is a factor of 150. So that's how this works. So in general, if you're looking for the number of factors a number has, start by writing that number as a product of powers of its prime factors. And once you write that down, you're going to add 1 to each of those powers and multiply those powers together. So let's do that for the number we're solving for, 576. So we'll have 576. As before, the first step will be to write this as a product of its prime factors. 576 can be written as 4 times 144. And I think this is 4 times 144 should be, I think, 16 times 9. And then this will be 2 raised to the power 4 times 16 is 64, which is 2 raised to the power 6 times 3 raised to the power 2. Yes, okay, this is it. 2 raised to the power 6 times 3 raised to the power 2. So we know that 576 is equal to 2 raised to the power 6 times 3 raised to the power 2. And since we know this means that number of factors that 576 is going to have is going to be 6 plus 1 times 2 plus 1. Since we're going to have the options from 0, 1, 2, 3 up to 6 for the power of 2, and then 0, 1, 2 for the power of 3 in this, right? Yes. So 6 plus 1 is 7 times 2 plus 1 is 3, which is equal to 21. So 576 is going to have 21 it's going to have 21 factors. Let me just go over how to do this again. The first step will be to write down the number as a product of its prime factors, which we did here. We wrote it as 2 raised to the power 6 times 3 raised to the power 2. So that's what we had here. The next step will be to look at each of these powers. So we have 6 and we also have 2. Then you're going to add 1 to each of these powers. That's what we did here to have 6 plus 1. And for 2, we had 2 plus 1. And then multiply those powers together. And in this case, where we had 3 numbers for 150, you start by writing down all these, getting all these powers, adding 1 to each of them, which will give you 1 plus 1. Then for the second one, 1 plus 1. And for the last one, 2 plus 1. And once you do this, you're going to multiply all these powers together. That's 1 plus 1 times 1 plus 1 times 2 plus 1 to give you 2 times 2 times 3, which will be 12, right? So that's how to find the number of factors that a number has.